When we were solving logarithmic equations, we had to use exponential forms to help us solve for x. Today, when we're solving for exponential equations, we're going to have to use the properties of logs again to help us solve for x. So let's take a look at what our equations would look like. So for example, 12 to the power of 8x, notice that 8x is elevated, it's smaller, minus 2 equals 22. So before we get too far into it, I need to solve for x. The problem is that whole x is up here as an exponent. All right, there needs to be ways I can bring that down because as it's locked up there right now, I can't really solve for it. Now, first things first, this whole piece right here, just think of it as a chunk I need to solve for later on. Before that, there's that minus 2. So actually, I can actually move that first by adding 2 on both sides. So look for the stuff kind of disconnected farther away from the x and move those first. So I've got 12 to the power of 8x equals 24. Now I can't divide that 12 over because it's not attached by multiplication. This is an exponent here. So I can't divide the 12 over. Now we don't know the opposite of this just yet. But let's think about this. I have an exponent that I don't want there. There is a property that I'm able to use to move the exponent if this was a log problem. So watch this. Let's say this was a log. If this was log, this is the exponent which can now move forward and get multiplied to the front. So I can rewrite this side as 8x times log of 12. But everything in equations is about equality. So if I log one side, I'm going to have to log the other. So this is equal to log 24. And now we don't have that x as the exponent anymore. It's down really on the same line as everything else. So think about it. I want to solve for x. I'm going to move this log term. It's being connected by multiplication, so I'm going to divide it off. So log 12 divided by log 12 cancels, but what I do to one side, I do the other. Now it may be tempting to reduce those, but that's not what we're aiming for right now. You can't reduce 24 and 12. What you're really going to do is take that to the calculator, log 24 over log 12, because if you don't see a base on it, it's base 10, and base 10 is something I could do on the calculator. So log 24 divided by log 12 comes out to a decimal. And I like to use at least 3 or 4 decimal places. I'll go with 4 decimal places. 2, 7, 8, 9. And that's pretty nice and easy to solve. We'll divide both sides by 8. Now we're finally getting x by itself. And yes, most of the answers we're going to have today will come out to these ugly decimal numbers. So let's go ahead and divide that by 8. And here we go. We'll go ahead and put 4 decimal places just for now. You'll see on worksheets or the instructions, they'll tell you what to actually round it to, but for now, more decimal places is better than less. So I'm getting a value of x equals 0.1599. And if you're curious, you can take that number and plug it back into the original equation for x and see if it comes out the same. And it will. Now, depending on how you rounded your decimals, it might be a little bit off, but it'll be really close. Let's go ahead and take a look at another one. 5 to the power of 2x minus 8 equals negative 6. So again, I can't start logging until this thing's ready to go. That thing's not ready yet because I still have this 8, which I'm going to add over to the other side. So 5 to the power of 2x equals 2. Okay, now I'm getting to x. The x is locked up here. I can move it by setting a log in front of it. But if I log one side, I have to log the other. So I've really got 2x times log 5 equals log 2. You remember, I'm trying to get that x by itself, so I'll divide that log to the other side. So 2x equals, now log 2 over log 5, that can be something I put in my calculator. 0.4307. And finally divide both sides by 2. And let's see what that comes out to. Getting a 0.2153. All right. Now I gotta be careful here. This next one. -9 times 15 n plus 8 up is the exponent plus 5 equals -41.2. Now please notice the difference between this symbol, which is a multiply, you see that dot's elevated, and this symbol, which is a decimal, it's lower. Okay, don't get this confused as -9.15. That's -9 times 15. All right, so just something to think about there. Now this is the term that I need to get by itself before I start logging. We've got two things to move, the -9 and the 5. If we're thinking about this as the variable, what we're trying to find, the -9 and the 5 would move first. Okay, so we have to subtract the 5 over. So -9 times 15 n plus 8. That comes out to a -46.2. Now I'm ready to move the 9 because remember I still need to get this by itself. So I'm going to move the -9. It's attached by multiplication, so I'm going to divide it off. So 15 to the n plus 8 equals -46.2 divided by 9 is a -5. Oh, it's not negative, positive, because negative over negative comes out positive. 5.133, and that 3 continues. All right, now I'm getting ready to figure out that variable. So we need to log this, so this whole thing moves forward, but if I log one side, I log the other. So n plus 8 times log 15 equals log 5.133. I need to get that n by itself, so I'm going to divide that log over. So once you get to this point, the steps start becoming the same as the other problems. So now we just got n plus 8, don't need the parentheses anymore. We'll go ahead and use a calculator on the right hand side. Log 5.133 divided by log 15.6040. And this time we're not dividing a number over, we're just going to subtract the 8. So that number minus 8 comes out to a negative answer, so negative 7.3, that rounds up a bit to 60. Okay, so I've had confusion in the past. People have turned this into a 9.15. That's a 9 times 15. Okay, so just notice the difference there. All right, same thing happens here. -6 times 19 to the negative x plus 7.3 equals -63. Again, this is the one I want to isolate. We're either going to move the -6 or the 7.3. Well, we got to move both, but which one comes first? And it's going to be the adding or subtracting number. So it's this one here. We're going to subtract 7.3 to both sides. So -6 times this 19 to the negative x equals -63 minus 7.3 is a -70.3. Now we get rid of that -6. It's attached by multiplying, so we're going to divide it over. So divide it over. We're left with 19 to the power of negative x equals -70.3 3 divided by negative 6. That's 11.7167. Alright, now that the x is here, we need to move it forward. We do that by logging this side and logging that side. So it's negative x times log of 19 equals log 11.7167. Okay, so we've got to multiply. We're going to divide this log term over. Negative x equals, so throwing this on the calculator, log 11.7167 divided by log 19.8358. And then we just want a regular x by itself, so flip the negative sign to the other side, divided by negative 1. We get an answer of negative 0.8358. So again, anytime we have an exponent where there's a variable in it, so x up as an exponent, we need to bring it down, and we do that by using our log rules, that traveling exponent. And once we log one side, we have to log the other.